Hi guys, I'm Jeff Martin, Director of Product Management and Operations here at SmartBear. Been in testing for what seems like forever, and we're really excited to answer some of your questions on video. Nick?
I'm Nick Bonifilio. I'm one of the sales engineers. I'll be joining in with Jeff to answer some of the questions that you guys posted.
All right, great. So might as well just get started, right?
Absolutely.
I'll read the questions off. You take the first stab at it, and then I'll correct all the stuff you say that's wrong. What is the best way to keep test data up to date across several databases?
Best way to set that up is to basically use the same data source for all of them if possible, if the technology that you are using does allow you to do that, and a lot of our products do. To have a single data source for all of them, that way you can just update one data source and it will spread throughout all of your test cases.
Yeah, I mean, there's a couple of different problems with test data. One is where you get it, two is how you maintain it, and then three is what's, I would just call the risk of using real data. All too often I see people use actual production data in their testing, which is a gigantic risk for a couple of reasons. One, not the least of which, legal. Most things that people use for test data are either confidential, personal information, or subject to one regulation or another, and test data tends to be less secure than production. So one thing that I just see a lot of people do is take real data and just say, this is my test data now. That's a really bad practice. Instead, somehow pseudo-generating kind of fake data is definitely the best way. It's pretty easy to write a quick database of a bunch of first names and just pull a random one and stitch it together to a random last name. Randomizing and controlling a set of data that is only used for testing and does not connect to the production data is a recommended best practice by just about everybody in the industry. How to maintain that as you go forward, theoretically, that should not have to change unless your product does. And when your product does change, there should be a process where you evaluate the changes in your product like you would for any test generation. And as part of that, evaluate what test data you're going to need to change and add or adjust. But for the most part, the term up to date, I would actually say means in synchronization with the functionality of your application.
Yeah.
I mean, if that makes some sense, right?
Yeah.
And I know, I think the question actually said, starting from scratch isn't an option. Yeah. It should be. There's nothing wrong with generating a brand new set of test data every time, as long as you automate that process. Doing it manually is certainly not an option, but you can easily build a test database really every single time and just throw it out afterwards.
For example, test complete with the data generation tool is really easy to set up, where you're just selecting what type of data you want in each column, selecting how many data sets you want, and hitting go. That's pretty much the entire thing.
Right, it's generating different data in different formats. Social security numbers are 3, 2, and 4 digits. End of the day, test data does depend on your application and what you're doing with it, but it's best to keep it simple, keep it to one database, one data source, I guess is a better way to say that. And if you can just throw it out and bring it back, great. There are also a lot of commercial tools out there for test data. Tons of really, really good ones that'll pseudonymize. I can't pronounce that word. Pseudonymize? Pseudonymize. Help me out here. How do you say that?
Pseudonymize, I think.
That's it. Pseudonymize the data that you have, and it will just do it fresh every time. There's a bunch of different tools. I can't even list them all off the top of my head, but not a bad way to start. All right. I'm just taking these in order that I saw.
Yeah.
How do others leverage their application's APIs to generate data for GUI, so front-end testing, of another application? I think they mean the same application, not another. Otherwise, I can't parse that question. So basically, how do we use the APIs to generate test data to be used on the front end? So I'll let you take the first stab at that.
Yeah, so as far as with our tools, one way that it would definitely leverage it is by utilizing the test complete and SwiftUI integration that we have between the two tools, which you could essentially kick off a SwiftUI test, perform an API call, take that data that you get from that call, and then use it in your test complete test cases. That's certainly one thing that some of our customers do that have both products.
Yeah, I mean, in general, I might say, when we hire new people here and we have to explain to them, hey, what's an API and what's a GUI and what's front end versus back end, you know, I usually explain APIs as that's what the computer sees, simplifying this greatly, and the GUI is what a human sees. Ideally, your data is the same throughout that process, right? Ideally, your data from the API, what the computer sees, should be pretty much the exact same thing as what the front end displays. I'd actually switch the question around a little bit. I think it's actually easier to go from, just for an explanation purpose, going from what the GUI to testing your APIs. It's relatively simple to stitch together your scripts so that it stores whatever you see in the GUI as a variable and passes that to an API test as well. And then you can run both sets of tests and compare the results. That gives you two things. One, it means you get end-to-end testing. You get to actually go through and see that the whole process is working. But more importantly, it helps with failure identification. So if you have the same piece of data in the same run going through your GUI and then your back-end API, and one of them fails, you now know where the actual problem is. If it's on the GUI layer, you know, great, you've got a GUI bug. If it's on the API layer, you've got a back-end bug, maybe a translation bug of some kind. So stitching together test data through in that kind of end-to-end testing really helps with one, coverage, but two, most importantly, the speed in which you can identify defects and get them fixed, therefore. All right. That's enough test data. Test data is like an exciting topic, but it sounds so boring. All right. I like this one. Let's dive into how to identify what to automate. That has got to be the #1 question I get asked ever. How do I identify what to automate? Or its cousin, how do I identify what not to automate? Which is probably a better one because it implies that you're trying to automate everything.
Yeah, typically what I find is that if you're trying to find something that you are trying to automate, it's more of like, I need to answer yes to all of these questions. Whereas if you're trying to find what can't I automate, you just have to answer yes. You have to answer basically no to one question.
A little bit easier.
Yeah, if you find a no, you can stop. But as far as like things that we can do with like figuring out what we can't automate, like things like, does this use dynamic values that really isn't convenient to compensate for? Is it one factor? If you're interested in time, might be like which one takes longer, which one's more time efficient. Another factor might be, for example, dynamic page properties, elements. Like if you're dealing with dynamic URLs, that's definitely a big thing. We can always like either parameterize those or wildcard them to compensate for that. But that again, that's only going to cover so many use cases. It's not going to cover everything.
Yeah, the question itself, right? Identifying what to automate. I think it implies what do I create an automated test for, and that's a trap I see a lot of people fall into. When you automate something, you're not just automating your quote-unquote tests. You're also automating tasks. And a lot of times, a test is actually a sequence of different tasks. Ideally, you would think about all of these different actions independently and make an independent decision on whether or not to automate this piece, right? Easy example, because it comes up all the time. I have to open up a website, log in, then I have to go through a CAPTCHA, and then I have to fill out this form, and then I've got to check on the back end to make sure the form data is filled out. Well, parts of that are really easy to automate and have a lot of really high value ROI. For instance, filling out the form. Not that hard to automate. It's a bunch of text and a bunch of enters. Easy to feed data in, but maybe logging in and going through a CAPTCHA, I mean, it's intentionally hard to automate. It's best to break it into discrete tasks and then each piece make an evaluation of whether or not it's worth automating. That does mean you have to maybe stitch together some manual efforts and some automation, but any good test management tool can do that for you. And actually most automation tools even have ways to do a manual intervention, like, okay, I'm all set. But don't just focus on, can I automate the whole test? Focus on the pieces of the test you can automate, because it lets you focus on the high ROI stuff. All right. I'm reordering these in my head here just to make sure they stitch together into some kind of narrative. So let's say, all right, concentrating on the validations that always pass rather than the ones that don't. Happy path testing is the other phrase for this. Do you have any thoughts on, I'm going to rephrase the question. What are your thoughts on whether you should be doing positive or negative test cases?
I mean, theoretically, you should be focusing more on the ones that don't pass than the ones that do.
I'm setting you up for that, yeah.
I know, but I mean, that's just kind of like my initial reaction to that is, well, if you know it's going to pass, why are you testing it in the first place?
Right. I love that when people put something in the regression suite and they're like, why are you testing this? And I'm like, well, 10 years ago it failed. Well, it's passed for 10 years? Maybe that's not high risk of failure anymore. Look, there are two different schools of thought here. Do you automate your happy path as kind of a nice smoke test to say, great, look, the latest release isn't complete crap, right? We've got something in here, it's not completely breaking everything. That can be valuable, but it's usually valuable at the beginning stages of testing, not at the end. By the time you get to the end and you're running it, all that happy path stuff should already pass. It's great though for like a CI/CD environment where you're doing some sort of continuous something or other, where you're triggering it. It's a quick double check, a sanity check, if you will. Other tests, time's valuable. Even automation takes time. If things aren't failing, don't test them. Yeah. It's really not any more complicated than that.
Yeah, like if like hypothetically, let's say you have 10,000 test cases, you know that consistently 5,000 of them are passing every single time you're flying colors without any issues. Why bother run? Like, you want to run them. If you want to run them every once in a while, that's fine.
Yeah, maybe at the beginning of a build, you're like, let's just make sure things work. But even then, figure out ways to slice that down.
Yeah.
Right. I see a lot of overlapping tests. If you have tests that are overlapping in functionality and they're all always passing, eliminate some of them.
You should, because theoretically, if you're working through like very similar workflows, you're probably testing the same thing anywhere from 5 to maybe 100 different times. And there's definitely like an overlap where you might have one test that does A and B, one test that does B and C, and then you might have another test that does A and C. What's the point of having all three? You can probably just do A, B, C, and have them all in one.
Right, especially if you're only using it as like a smoke test.
Yeah.
Okay. I kind of like this one. It's related, but it's a little different. Scenarios we are automating should be end-to-end, not modular, because that's mostly covered in unit testing. Less of a question, more of a statement. What are your thoughts on that? I'm not sure how I feel about it.
I'm not sure. When I initially read the question, I wasn't sure about it either. I kind of did a double take where I was like, wait, what? I was like, the whole point of like what the industry is trying to do is make things more reusable, not less reusable. And that's kind of the general direction of the industry as a whole. So that question kind of got me a little bit confused. Unless they're using, because especially when they're talking about, I believe that was the same person who might have been talking about like moving to more of like an
agile thing, yeah.
style development, you would think that having things be reusable and more modular would play into the agile methodology.
The question's almost a false premise in a way, and I'm sorry, I'm not making fun of your question, but I am a little. Because a good modular system, you should be able to take the modules and make an end-to-end test out of it really quickly.
Yeah.
Yes, if you're covering something completely in unit testing and is highly segmented and super siloed and it's just in this little thing, maybe don't bother testing it all in actual end-to-end. But fundamentally, the end-to-end framework should be set up to be able to benefit from the modular type framework. In an ideal world, it's all the same framework.
Yeah.
Most unit tests should be able to be brought in. And then, look, unit testing and end-to-end testing tell you different things. At the end of the day, unit testing tells you if one little tiny function works. End-to-end tells you if all the functions work together. Those are very different tests. But a good end-to-end is stitched up or stitched from all of the modular tests shoved together.
Yeah.
At least conceptually, I know there's differences. Right?
There's obviously some filling in the blanks and stuff too, where there might be some gaps here and there between the actual units themselves, but that's part of that still plays into the modularity.
Yeah. Here's another one of those, like, it's kind of a question, kind of a comment. I think we just wanted us to talk about the misconception that automation is quick, which that is a misconception.
Yeah.
Nothing's quick. Take it away. Let's go with your thoughts.
There are certainly instances where automation can save you time. That is only one factor in whether or not automation is a good fit. There are other factors that can go into it. For example, reducing risk. If you're more worried about quality than time, sometimes automation can basically compensate for things that a human can't. In terms of, like, for example, humans make mistakes, and also software. I mean, I will admit that software is made by humans, so it is inherently imperfect, just like we are. But if they do work properly, there are a lot of things that they can compensate for, like eliminating the majority of human error in manual testing, things like that it can compensate for to help make sure that things aren't missed. That a manual tester may miss, may or may not miss. Another factor can be just overall cost as well. That can be a factor into it too.
Yeah, I mean, it's almost again based on a false premise. Automation is quick. Your goal of automation is not speed. The goal of automation is varied across a lot of different applications, right? Depends on what you're trying to do. Automation can make you go quicker, but that's not inherent. All automation does is what it says, automate an actual task. The reasons for that could be quality, like you said. It could be speed, right? Computers can do things faster than humans. But it could also be reusability. It could also be documentation, so that you don't have to do that. I've seen plenty of people do automation solely for documentation generation.
Yeah. Scalability plays into it too.
Scalability, right. Speed should not be the main goal of automation, but if you're doing automation well, you should probably get some speed out of it. Every single thing you automate has a different return curve on the effort spent to build that automation and the return on time saved. Nobody in their right mind would spend a week building an automated test for something you run once a year that takes 2 minutes manually, right? So there is that curve. I think very often automation engineers just like to automate everything without thinking about that curve. When people first start automation, the first thing I tell them is, hey, focus on the things that are painful to do manually. Automate those.
Kind of a general rule that I learned in like some of my development study work that I did was that in terms of like whether or not you should actually automate something, it's basically a direct ratio on how much time you're actually going to dedicate to automating the task versus how much time it's going to save you over X amount of years.
There is one other variable that I think the more rational of us kind of omit, which is there's a huge benefit in automating the stuff people hate to do. Even if it's actually a negative ROI, sometimes if the manual testers really hate some tasks, automating that is a great way to get them on board with things like increased automation.
Yeah,
that
definitely.
So that kind of human interaction, everybody kind of forgets about that in ROI curves and everything else.
Yeah, that definitely plays into it too. I'm speaking strictly from the engineer's perspective, who's not worried about ROI.
Right.
In terms of in terms of whether or not this is worth investing my time into, how much time is it actually going to save me, and it gives a direct quantitative result on whether or not it's actually worth spending the time doing.
Right. I mean, to me, it's like dishwashing. I've automated that with my dishwasher. It really wouldn't cost me that much more to tell the kids to go wash the dishes, but I don't have to listen to the dishwasher complain. All right. How do you determine the life cycle of a test? There's a lot in that question.
There is a lot, and there's a lot of variables. Like, for example, how often does your application change? As far as the test case is concerned, test cases are obviously going to be volatile in some way, where they're going to have some sort of volatility, and if you do need to tweak it, it's normally going to be just small tweaks here and there, and then it will evolve over time. It's very rarely going to be hey, we need to get rid of this entirely, unless it's one of those tests we talked about before, just like getting rid of the ones that always pass. But unless it's one of those cases, and in most cases, it's just going to be hey, this is going to slowly evolve over time. It's unless you're going through some type of overhaul, it's probably going to be the former, not the latter.
I mean, there's two pieces that everybody doesn't quite pay attention to, I think, with a life cycle of a test, which is the beginning and the end. Whether or not to start a test is something I think we've talked about in almost every question we've had here, right? What do we automate? What's the best way to keep test data up to date? Like, there's a lot of pieces in there about when do we design a test? When do we start doing a test? What we haven't talked much about is when you stop that test. We touched on it briefly, I think, when we said, hey, if this thing's always passing, maybe figure out a way to consolidate. But fundamentally, what that question boils down to is every test should have a declared purpose. Why are we testing this? Is it a high-risk area of the application? Is it a point that fails a lot? Is it because if we don't, some VP somewhere is going to get upset at us? Every single test should have a purpose. If you don't have a purpose for a test, it has reached the end of its life cycle. That's really what it boils down to. And having a process to evaluate which tests you're running and what purpose they have, so that when your application changes or your environments change or something changes, you can apply that process and remove tests, end tests, is really important. I have lost track of the number of frameworks I've seen who are doing things like testing an IE at 8. And it's like, well, why? Well, because we have been. Well, your application says it only supports IE 11 and better, so why are you running for 8? People don't take that change and actually apply it into their frameworks.
Yeah. Kind of reminds me of the Netflix show with Marine on the Tidy Up.
I haven't seen that.
It's this whole premise.
It's just like
behind
just up.
It's kind of like this whole premise of keeping tidy and tactics for reducing clutter and stuff like that. So I feel like it's kind of funny how it doesn't apply just in the software. It applies everywhere. But
I haven't seen the show, but I know how I keep clutter.
I haven't watched it either, but I hear a lot about talking.
I'm incredibly careful about what I bring in, and then I'm really aggressive about getting rid of things. And I think those two things apply to your tests as well.
Yeah.
Be careful what you go and create, because it's hard to get rid of stuff once it's there. And every once in a while, go through and be like, I haven't opened this box of stuff since I moved a decade ago. Maybe I should just throw it out. All right. How do you track automation coverage? Whew. There's like 4 definitions in there. I haven't seen 2 people agree on what automation coverage is in a while. I'm gonna put a ton of thought into that while you're answering. So you go ahead and answer because I'm gonna think about it. I'm putting you on the spot. That's fun.
I feel like that's a relative question depending on who's asking it. There's certainly a bunch of different directions that you can go with that. It's a lot of it plays into like basically like what you're doing now, what your ideal test coverage is. Like, do you actually like when you say like test coverage? Does that mean like where you want to be? Does that mean actually like 100% of everything of your application? Does that mean like just specific types of tests that you're worried about? There's a lot of stuff that plays into that.
Yeah, your application type really dictates what you want to cover. I've seen automation coverage be considered code coverage. Am I testing every piece of code? I've seen it considered as function coverage. Am I testing every function of the application? I've even seen it as, here's all the manual tests. Here's the % of them we've automated, and they call that the automation coverage. It's a little controversial to say this. I don't think it's valuable to track, for instance, the percentage of your application covered by your regression suite. That's a bad way of thinking of your regression suite. You don't want that to be 100% of your application. It shouldn't be. If you're doing it that way, that means either you have a very flaky application that you're really needing to keep track of, or you're just over-automating. Anybody who tells me they're at 100% automation, the first thing I say is, great, so no humans use your application, right? Like if your application is only used by other computers, you can get to 100%. But if you're used by humans, at some point a human should test the application. Some circles that's controversial, and others people are be like, yeah, that's common sense. Focusing on coverage percentages tends to have a very poor reward. It's more of a question of, am I automating all the things I should automate, than am I automating a good enough % of some arbitrary measurement? That's really how I would phrase that. I don't like tracking automation coverage, at least in terms of testing and functional testing. Now, if you want to track automation coverage, both unit testing and the more traditional functional testing of your code, that's a little bit different. Theoretically, every single piece of your code should be touched by automation at either unit or integration or systems level. Somewhere in there, you should be testing all of your code, but hopefully at the unit level. But yeah, automation coverage is sort of this weird arbitrary statistic to me that I've never seen been consistently applied, and I frankly think it creates perverse incentives for people to over-automate. How do we incorporate performance and load testing? And this one's specific to desktop applications, which is, usually we talk load testing or performance, we're talking web. But for desktop applications, performance and load testing. Interesting. Want to stab at that?
Yeah, I mean, obviously there's going to be testing. It's not just load testing front end, it's also testing back end as well. You can get, especially like in hybrid applications, like a lot of applications are now, where it's going to have require some type of internet connection, whether it's like your conference call software that you're using, like as an example, or maybe it is like just a Java application that you're spinning up on your actual machine that is local. Somehow that's going to tie to some type of database for information, most likely, and actually like running through those is definitely just as important. Obviously, it's going to require a little less because you don't have to worry about like network configuration and all that things that might factor into testing a web application in that sense. But it's still, I would say it's still just as important to do. I just know that a lot of tools that are out there do focus strictly on like web performance testing in terms of like actual load times, API response times, that type of thing.
Yeah, Carol, who asked that question, I almost wish you were here so I could ask for clarification. because one, you've separated performance and load testing, so I'm assuming you mean something different with performance than pure load, which makes me think maybe responsivity of the application. You know, do I get a response when I click a button really quick? Or perhaps things like CPU usage. So I'm not entirely sure what the question is, but in general, I would say that people make the mistake of completely separating out performance and load testing as separate activities from your normal functional testing. Especially in desktop applications, they can and should be built into your framework. So I'll take the responsivity performance as an example. If I'm worried about how fast the next piece of my application loads after I click a button, you should build into your functional test a timer and just say, hey, great, here's how long that took. It's easy enough to write a quick validation against that timer. That should not be a separate task. Do it at the same time you're running your function test. Make it one of the criteria for the functionality to pass. Separating out performance specifications and functional specifications can be valuable in some applications, especially in the web, but I think for desktop applications, I wouldn't. Just because you're in the same environments already, your coverage should be the same there. Load testing for desktop applications, that gets more complex to me. I'm assuming we're talking about things like CPU and memory usage there. There are lots of ways to do that. Again, I would encourage integrating that into the functional tests as opposed to setting up a separate test that's running concurrently and actually pulling the information back and forth. For desktop, I would generally recommend as integrated performance and load as you can on your functional piece. Unless we're talking desktop server, that gets more messy. But if it's just pure all on one desktop, it makes sense to me to do it that way. Yes. I don't know anything else really to go there.
I think there was the other. Did we already address Peggy's question?
No, I think you're right. Peggy had a question of how long does it take to become a test complete expert, I think?
Yeah.
I mean, what, 2, 3, 4 decades? No, I'm joking. Boy, I don't know what expert means there. You should be able to learn the basics of test complete in 2 months tops. But like anything else, it kind of depends a lot on who you are, your background, your intelligence, whether or not you've experienced automation in other places. That's a hard one.
Yeah, I mean, I work with the tool every day, and I'm still learning things about it.
Yeah.
I'm working with it for a while now.
I'm not, but I'm really, really smart. So.
Yeah. You used to.
It's just a piece of cake. All right. Well, anyways, guys, thank you very much, and I think we answered all the questions. All right, this was fun. Thanks, guys.
Thanks, everyone.
I just hit my laptop.